Hello, in this video we are going to look at solving quadratic inequalities. This is going to be more of a review and some key pointers rather than teaching the whole concept from start to finish, because we already covered in class, but a couple of people wanted a refresher on this, so that's what I'm going to attempt to do in this video. While I might not follow these slides explicitly, I'm going to keep using the slides that we've used in class because I think that'll help keep clarity in the concept rather than just going off on random tangents. This will help me stay directed with what we're going to do. So, quadratic inequalities. I'm going to start first. Let's think about what a regular inequality, a linear inequality, looks like. We might have something like 3a plus 2 is greater than 5. Okay. Now, if we're asked to solve this, okay, or we're asked to solve any inequality, we're asking what values, okay, of, in this case, a, make this true. Just like an equation, we're asking what values of x or a or m make it true, and it just happens to be 1, or in quadratics it's 2 values that make that true when we let it equal to 0, when it's got 2 intercepts. When we're solving this inequality, we're asking what values of a will make this whole thing true. And so keeping that in mind, we can solve this algebraically, where we just reduce the equation. So I could take 2 from both sides, that cancels. I get 3a is greater than or equal to 3, and then divide both sides by 3, that cancels, and it turns out we get a is greater than 1. This is saying, okay, for the original inequality, any value of a greater than 1 will make this true. So that's what we can think of in this case. Now, quadratic inequalities, if we move on to our idea of quadratic inequalities, okay, we have this x squared minus 5x minus 14 is greater than 0. That is asking what values, okay, if we're asked to solve, I should say, when we're asked to solve, that is saying what values of x make this true. Okay. Now we could try and go about factorizing in the normal methods we go down when we're solving an equation rather than inequality. Okay. We start factorizing. In this case, we can factorize via inspection, and we get x minus 7 bracket x plus 2 all in bracket is greater than 0. We can't use the null factor law. Okay. The null factor law says only works if we have something, whatever in the first bracket, times by something in the second bracket is equal to 0. Then, if it's equal to 0, it must be, through common sense, one of those two things must be 0. So either a equals 0 or b equals 0. We can't do that with an inequality because this only works by the concept of 5 times, say, 0. Well, that gives you 0, or 0 times 5 equals 0. So the null factor law works when it's equal, but when we have an inequality, that's not the case. We have this annoying issue here, and we just can't say x minus 7 must be greater than 0 and x plus 2 must be greater than 0. That doesn't work at all. That doesn't hold true. So we run into a dead end. So how can we work forward from this? And it's this big highlight thing down here, is we must sketch it. Now, why are we wanting to sketch x squared minus 5x minus 14? Well, I'm going to do something here. I'm going to do something here to try and put the graphing in perspective. I'm going to say let x squared minus 5x minus 14 is equal to y. I'm going to call that whole thing y. By calling that whole thing y, I want to know when is y greater than 0. So if I choose any values of x and I sub them in there, and then that's going to give me this final y value, when are those y values, okay, for what x values does now y become greater than 0, and we can now much easier see this on a graph. Okay, by letting whatever that original inequality was equal to y, what x values will end up making y greater than 0. So this previous graph, we get x minus 7, x plus 2, so that means our x-intercepts. And this factorization is still handy, because if we did let it equal to 0, and that's a big if, we let y equal to 0, well, it gives us our intercepts, which can help us sketch it. And that's what we're always going to do. In all these, we're going to do a little sketch. You don't have to do a really nice, fancy graph where it's all properly labeled in coordinate form and you've got the turning point. You don't need any of this. The sketch in these problems is just to help you identify when y is, in this case, greater than 0 or less than 0. Okay? So here's a sketch of it. We can see we have one intercept at x equals -2 and another intercept at x equals 7. Now, I said let x squared minus 5x minus 14 equal to y. Therefore, I'm really asking, when is y greater than 0? Well, greater than 0, all my y values are whenever my y values exist up here. That is y greater than 0. When does my line have that region? Well, the line here, all of those points, y is greater than 0. All the coordinates along the line here is y is greater than 0. The next question, the original question that we asked for, was what x values make this occur. Okay? So we need to now read off, and this is where there's this weird transition. We want y greater than 0, but what are the x values that give me a y greater than 0? So I need to read my x values here, and we can just look at, well, if I know that is 7, and I know that is -2, I can see, well, anytime I make x over here, looking in this zone over here, okay, so if x is greater than 7, well, we can see from the graph my y is greater than 0, therefore the whole equation is greater than 0 as required by the inequality. But also, what about all the x values down over here on the left? They also give me a y value greater than 0, which is a requirement of the inequality, so that's fine. So I can also say x is less than -2. Okay, so there's two zones. I can make x less than -2, or I can make x greater than 7. In either of these cases, okay, y is greater than 0, therefore the inequality is true. So I'll do this example quickly to have a go. So I'm still going to let it equal to 0 so I can sketch the graph. So let's start with let x squared minus 7x plus 12 equal to y. Okay? So therefore I'm asking, when is y in this case less than or equal to 0? So this time we want y values that are negative because we want them less than or equal to 0. What are the x values that make that occur? Well, I'm now going to let y equal to 0, so I get x squared minus 7x plus 12 is equal to 0. I know the a value is 1 in front of the x squared, so I'm going to try and factorize via inspection first. So I get multiply to give me 12 and add to give me -7. That's going to be x minus 3, x minus 4. So from that, using the null factor law, we get x is equal to 3 or x is equal to 4 for our intercept. So let's put in axes, and it's a regular shaped, and the other thing is the positive x squared term, so we know it's going to be a U shape, not an N shape. There, just doing a little sketch. I'm going to call that 3. And do this in double. Let's take this across. Hold on, sorry. I want to make the graph nice and clear for you all. I'm going to call that one that 4. Okay, my intercepts are at 3 and 4. I know it's a U-shaped graph, so it's going to look something like coming down through like that. So there's a rough sketch. I don't know where the turning point goes down to. That doesn't matter. I just need to have an idea of where the intercepts are and what the graph is doing. Okay. Now I want to know, like I said, when is the y values less than or equal to 0. So what any x values that give me a y values down here. That is when y is less than or equal to 0, including that. Well, that means any x values in here give me these negative y values, so that's my happy range, that's my zone that gives me the required y. So what is that? Well, we can see from the graph, from the sketch, x needs to be between 3 and 4. Now here's where a bit of nuance to the question is. Between 3 and 4, that gives me negative y values, that's fine, okay? Which is what I want. But I also want, going by the original equation, y being equal to 0 is also fine, because it's less than 0 or equal to. So the point itself of x equaling 3, right there, that gives me y equals 0, and x equals 4, that also gives me y equals 0, so I can include them in this case. That's an overview of what we're trying to do, and my camera's just stopped working. There we go, we're back on. There's an overview. I hope that helps. If you have more questions, please ask me in class. Or come find me before, after school, during lunch, I don't mind. But please do. That's it. Or you can also comment on the video or in Google Classroom.